For my biomechanics project, I'm looking at the radius of gyration as it relates to angular velocity. More specifically, I'm looking at the radius gyration of two different flipping positions, tuck and pike, and explaining the relationship with angular velocity. As we know, the formula for angular momentum is H equals m times k squared times w. Both flips you're about to see flip about the transverse axis about a point outside the body. As we learned about in class, the radius of gyration is a measure of how far away a body's mass is distributed from its axis of rotation. Given that the body is not symmetrical, masses in the body can't be concentrated to a central point. In class, we talked about spinning a small cylinder versus a large tire, and it was concluded that spinning the small cylindrical object would be easier than spinning a large tire, given its smaller radius of gyration. The same can be said for flipping. Flipping in a tucked position will be much simpler than flipping in a piked position because the pike position has a larger radius of gyration. Assume that for both flips the angular momentum is the same. We are also going to assume that the mass is consistent given that the flips were performed consecutively. The K, or radius of gyration of both flips, is different, however. For the first clip you will see, it is in a tucked position, the second clip is in a pike, and the third and fourth clips are just repeats of the first two clips done in slow motion. Comparing the timing of the two flips is easier in slow motion. The time for the tucked flip to be performed is 0.99 seconds, and for the standing pike is 1.23 seconds. Given the formula for angular momentum, and assuming angular momentum and mass are equal for both flips, radius of gyration and angular velocity are inversely related. Thus, as k increases, angular velocity decreases, and vice versa. If we assume an equal mass and angular momentum for both flips, the slower velocity of the standing pike was due to the larger k, or larger radius of gyration. It is also true, then, that the standing back tuck, which has a smaller radius of gyration, will have a faster velocity.